Threads and queues. How can I accelerate my application by outsourcing tasks to threads? Welcome to my session about threads and queues. Today I would like to show you how to accelerate your application with the help of threads and queues. For those who don't know me, my name is Frank Lauter. I'm an Embarcadero MVP and I have been programming in Pascal and Delphi for over 35 years. For more information, please visit my homepage, where you also can find information about my services like source code review and consulting. My favorite topic is the development of FireMonkey application, for which I also offer training in your office or remote. As well as my blog From Old School to New Frontier on Blogspot, and the German version of my blog, which can be found on the Embarcadero homepage. It deals mainly with my favorite topics, MVVM, FireMonkey and my FireMonkey development kit, which offers many useful features also for VCL developer. In order to spread these topics even better, I've started this year by publishing video series on my YouTube channel, Delphi Profi. Of course, I'm happy about everyone who subscribes to my channel and links to it. In the past, it was often the case that many developers did not use threads because the use of threads was not so easy. How often did you hear this? Threads are done by Peter and he is on vacation, so that's why I don't use a thread in this method. But with the introduction of the parallel library, nobody could talk himself out of using threads. A T-task run can simply be used at almost any point of your application to move the execution into the background. So far the idea. Of course, the use of threads means more than just wrapping any code fragment with a T-task run. This simple way of using threads is usually based on the assumption that the executed code also works in the background without errors, so-called good weather code. But how do we do it the right way? Error handling is not always easy, even without the use of threads. What happens if an error occurs in the middle of a complicated processing? How do I get out of the fifth sublevel? Do I throw an exception or do I pass an error state upwards? These are questions that every developer must face every day. And who doesn't mind if a component throws an exception every time it is debugged? The good weather code problem is not limited to threads. Would I expect an error in my code? Rather not. Otherwise, I would do something about it in advance. But while addressing system functions or external sources, error can always occur. If I get the error disk full from the database, I can hardly do anything and must surely abort the processing and inform the user. When using threads, error handling becomes even more difficult because I might have to inform the user about the error. I move the save method of an address into a thread. The user clicks save and the dialog is closed. If saving now fails, where is the data? Do I have to open the address dialog again? Is the data lost? This example shows very clearly that using threads does not start with dividing a class from tthread or writing ttaskrun. In order to use threads, as a developer, I have to mentally adjust to a different way of thinking. During my consulting activity, I often see foreign source code that uses threads and shifts the execution of a method into the background and then wait for the result, because it's needed for further processing or by the user. These kind of threads are hardly usable and make the application even slower. If I can't close the dialog until I'm sure that the data is safe, why start a thread? Of course, we could rewrite this procedure with a few changes to ensure the functionality is implemented as it should be. So first of all, disable the button so that the user is unable to click it twice. Then maybe we catch a reasonable error message. Of course, synchronize it again. And in the other case, of course, don't forget to re-enable the button again. Voila! We have a procedure that allows the user to click the button, the application remains reactive during the processing, and also a reasonable error message could be displayed. Besides the correct location of threads, there are of course many other considerations that I need to consider beforehand. I hope it is clear to everyone. Never do UI stuff in a thread or from a thread. To update a visual component, even if it's just a simple assignment of a text to a label, I need to synchronize the call with the main thread. There are two methods of this, synchronize and queue. The queue has nothing to do with the queues that are in the title of the session. Any method I want to move to a thread should be usable without a thread, at least to check it with a unit test. When using threads, I distinguish between two types. First, the so-called shoot and forgets. Threads that do a task and then automatically terminate themselves. And second, one or many threads using the same code at the same time to solve similar tasks but faster. A third type would be the parallel pipeline, the concatenation of several processing stages to process data, whereby each station in the pipeline can use a different number of worker threads. I like to use shoot and forget threads in places where I don't expect an error to occur during the processing. But let's look at a simple variant first. Surely you can simply write tTaskRun into a button click method. I don't want to raise my index finger in this session and point out that you should never write this kind of code in a form like this, and that there are better methods available, like my Delphi MVVM framework for example. But I truly want to be able to do unit test of this method. Of course, when multiple threads accessing the same code, much more considerations come into play. We like to talk about Threadsafe here. It's mostly more about the possibility to a method that is reentrant. The possibility of two or more threads calling the same method without the thread hindering each other or even the fail of the functionality. So for example, if you use a global var in this method, there is a good chance that this is not the case. For example, if several threads want to modify the same data structure, a list, an array, or a dictionary, the access must be designed in such a way that only one thread can access the data structure at a time. There are several methods for this. In the past, a critical section was used for this purpose, but nowadays it's more common to use a spin lock, assuming that the period of time in which the access for the other threads must be blocked is very short. But why do we need queues mentioned in the session title? Let's assume you want your application to perform recurring tasks. Only the data changes. The classic example is logging. Normally, we don't want our logging to slow down the application or change its timing. A call to log whatever should therefore immediately return, even if the hard disk has to spin up first, or a web service is addressed for this purpose. Of course, our application should remain 100% reactive, even if a DLL must be loaded for the first call. If the log event occurs faster for a short period of time, the queue can store and handle the processing. Of course, this does not work if the application permanently generates more events than the processing routine can handle. In this case, the queue would eventually overflow or the process would have to be interrupted. Other example would be to process a list. In this case, we encapsulate our data to be processed in an object. The object also receives a status indicator wherever the task has been completed. We don't want to start 10,000 threads just because our list has 10,000 entries. So in this example we use a limited number of worker threads, which get a new record from the list every time a task is done. At the end there might be a status message that everything is done, or as a result the failed data list that could not be processed. Which type of threads we are using depends on the field of the application. If you have to create a thread for a task that is very short in execution, the overhead of the creation could be longer than the execution itself. In this case, it would be better not to use a thread, or use an already created one. A thread that is waiting for an event will start processing in a few picoseconds, so almost zero overhead.
Let's take a look at how it would be done in practice. So we create a new program. That should be enough as UI for now. Contrary to the usual procedure where I directly show finished code or excerpts from my FDK, in this session I would like to go away and show line by line how one would program something like this. The thread can't do anything yet. But we'll see if the thread can be created and released. If the thread waited in the event, it could be terminated immediately. Are we sure that the thread was running? As we see, the thread was not started at all. Why is that so? We created the thread with suspended. Therefore, we have to start it manually. This time it worked. But the thread can still be stopped immediately. For this demo, I want to adjust the window position. I don't really like the manual start. We have to do it differently. If we don't start the thread with suspended, we have to make sure that all other variables are created correctly. And as we see, this works. There are many ways we can extend the thread now to get the necessary functionality. We can program it so that we always have to derive a class from it first. We could override a virtual method. Or we could just pass a procedure. At this point, I would like to do two different types of implementation. Let's just start with the timeout first. So that should do it. We don't need anything here. With the first call, we simply set the value. And in case of timeout, we just call it. We can check for the other values here, but for now that should be enough for us. At this point, we can then pass a procedure. I see. Thanks. Now it works. Then all we have to do is call the procedure. Right now we don't have an interface, so we use nil. Now, of course, it would be nice if we could call. We will simply do this without parameters.
Quatsch.
And just set the event, then the procedure should be called. So let's test it. It works. What we have now is called a pre-produced thread. So we don't need any additional CPU cycles for a call and no overhead to create for every call. Now we can just use a button. Since the thread already exists, we can simply call run. Create and run. We can also press the button twice. But this only works once, because the event is resetted each time. Let's take this call out. We create the thread and say run. The thread runs. Our application remains reactive. And if we do it twice, the event is set and executed twice. And as we can see, the call succeeds immediately without any delay. This is of course only visual and not measured, but the time from click to call is a few picoseconds. Then we take a look at the heartbeat variant. So I do something else now, which is not so nice. Don't do this. And we have a heartbeat that we can use to see if our remote application is still running, if our TCP/IP connection is still active. There are 100 reasons to use a heartbeat like that. If we need it, we could do it like this. But not like this. Okay. This was just for the sake of completeness. To turn a simple thread into a working thread, we need to enable the thread to process data. So we want to give the thread the data and it should be processed. I have already started to program this by implementing a callback with an interface, or I can pass a procedure which is then called by the thread with the interface. But I want to do it a bit different, so let's change the name first. Let's call it Q Worker Thread. T. Now we also use T here. And here, too. Though we also need a Q here. Of course, we first have to implement this. Let's start with a Threadsafe queue. Why strict private? There is no special Delphi related reason for this, I just use this as a flag to indicate that these methods are implemented in an interface. If I use more than one interface for this class, I would put a comment here with the name of the interface. So again, this is just a flag in my source code to remind me, this comes from an interface. I could use the queue instance direct for the spin lock, but again this is also just a flag for better reading and I always use a separated sync object. Normally I would not use tinterface object, because I have a predefined class for this in my FDK and the class just creates a sync object for me. As I do not use my FDK in this demo, I just create a sync object, here. From my point of view, the source code is better readable and if I recognize an sync object or a class that is inherited from interfaced class with sync, I know, hey, this class is Threadsafe. It's just because this is a better readable source code. This was difficult. As simple as it can be. So we have a very simple thread, we have a very simple queue, which is reference counted. The only thing we also need is WorkData. Again, we would keep it really simple for this project. Our WorkData should only contain a file name. Of course, we could just pass a string to outThread or the queue. But with an interface we are on the safe side. We could simply extend it, it's reference counted and with this everything is fine. Let's just include this simple queue into outSimpleThread. We could use dependency injection. But for this little example we just create the queue inside the thread. Just create the queue here. Then we need our WorkData. Why on earth is the help still showing word data? Okay, a fresh restart of the IDE solves the problem. Should not happen, but who knows?
Yeah.
Of course, I am now facing the same problem as always when preparing such a session. What should I show? Well, I have decided to implement a file hasher that works on directories. Probably you could just put such a routine into a task run, as I said, always the same problem with examples. I don't want to show you a routine that's polished to the last detail, I just want to show you how to use threads and queues. Let's just start. What we need in any case. Is there any case we do not need this unit? We need hashing. We need our thread. We probably need out queue. And our WorkData. Productive interfaces, I like to call, starting with I can. I can MD5 files. I would like to be able to add a directory. And perhaps I like to add some logging. Optional async. Sorry, we don't want to use the FDK. So far so good. YFD text? In the old days this stands for floppy disk, and I just keep my naming this way. Okay, for this test I put a static path here. Okay, now the do directory. This looks not so bad at all. Our idea was, just do it synchron for the beginning, so we could debug it better. Perhaps add some error handling, first. Okay. Let's do some cleanup. And some more directories. Okay, now it took some time. Now, we should log a little bit, what is happening inside. One second 800 milliseconds. Without a thread. And now we have a little bit more files. 2378. Well, my system is very fast. Now let's add the async stuff. So in the add directory procedure, we add our WorkData to the queue. Of course, we have to implement the run procedure. This is really simple. Synchron. Asynchron. Faster. Although we have the thread and queue overhead. And comparing to the synchronous version, our application keeps 100% reactive all the time. Thank you for your attention. Please help me to grow my channel by subscribing and hit the like button if you like to see more content.
There's a fire burning out on the street. I can't bear this heat. You claim it was my fault, but I know it